Hello, everybody. My name is Gracelyn. Thanks for coming to the AMC 10 mock test organized by the Logistem Math Club. Today, we will do the test first, and I will briefly address questions after. After the test is officially over, there will be a problem review session hosted by Jennifer, Chris, and I, and we will explain some problems on the test for everybody. Enjoy your time! If you do choose to check yourself, it's 6 points for a correct answer, 1.5 points for an unanswered question, and 0 points for an incorrect answer. Your answers should be submitted into the Google form, which was posted at the beginning. Okay, so then if not, we will start officially going over the solutions. Yes, if you don't want to stay for the problem review, you can choose to leave now. But okay, so this is the correct series of answers for the problems. Okay, so just take a few minutes to check them over. If you have any questions on the first 15 problems, send a message to either me or any of the co-hosts. And to see what you answered, again, check your emails because of a form containing what you submitted should have been sent to your emails immediately after you submitted. Okay, so for now, please only send any questions you may have on the first 15 problems to either me or Jennifer, who is a co-host of the meeting. So that should be an option. Okay, so currently the questions we're going to go over are 2, 9, 10, 11, 12, 13, 14. And okay, so now, Jennifer, if you want to start presenting solutions to 2.
Thanks, Gracelyn. I'm Jennifer, and I'm gonna now explain numbers 2, 3, 9, 10, and 11. For 2, the twist here is that it says how many students do not play soccer and do not play basketball. So we could solve this by setting x to be the number of students in all in the classroom. So then there are x minus 17 who do play soccer and x minus 15 who do play basketball. So we could use the principle of inclusion and exclusion to count how many students are there in total in variables. So x is equal to the number who play soccer plus the number who play basketball, then minus 4 who play both sports, plus 6 who play neither sport. And now we could solve this equation for x. It's 30. Does anyone have any questions? If not, I'll go on to 3. So for this problem, we could try to construct a subset with as many elements as possible. We could do this by first including the least elements. We could do from 1 to 27. And then we'll go on to 55, such that these differ by 1 more than 27. And then starting from 55, we can go onward to 80. As we can see in each interior, at most they differ by 26 and 25, which are both less than 27. In all, this subset, which satisfies the property, has 53 elements. And to see that 53 is the most we can get, we could think about for each mod like if for each mod 27, if we have two elements of the same mod, that means they must differ by 54. Because it can differ by 27, but if it differs by 81 or more, that's too large in the range. And we can also only have at most two elements of the same mod. Since if we have three, then if we order them from least to greatest, each consecutive has to differ by at least 54, which is out of range if we consider the greatest versus least. So that means that we could guess that the answer should be 2 times 27. However, if we try to construct that, like if we use this as the basis, he knows that we can't have two or more elements mod 0, 0 mods 27. Since then, if we have 27 here, we'll have 81 here, which is out of range. We also can't go down to 0 either. So it's actually 2 times 27 minus 1, which is 53. Is that clear? Sure. I'm gonna now do 9. We have Mark, which is on 0, 0, and Victor, who is on 10, 0. And now let's say Mark moves to point 0y. And that means that when Mark moves up y steps, Victor would move left 2y steps. So Victor would be on 10 minus 2y 0. And now the distance between Mark and Victor is 10 minus 2y squared plus y squared, which is equal to 5y squared minus 40y plus 100. And in order to minimize this distance, we'll minimize the quadratic inside. To do so, we could complete the square such that the quadratic becomes 5 times y minus 4 squared plus 20. You could see that y is minimized, that the quadratic is minimized when y equals 4, and then it'll equal to 20. So the minimum distance would be 20 or 2 root 5. And that Fy is when Mark is at 0, 4 and Victor is at 2, 0. Okay, if there are no concerns, it's time for problem 10. So we have that the distance between alpha and beta is 39. The distance between alpha and gamma is 52. And the distance between beta and gamma is 65. And we have delta such that it is equidistant from each of these points, alpha, beta, and gamma. We could say this problem turns into finding the circumradius of triangle ABG. That's like the radius of a triangle is the length of a point to all the other point to the vertices of the triangle, such that all the points are equal in length. And that's the rate. For a fun fact, the radius of the circle circumscribed. So the tactic to find the circumradius for this triangle is note that ABG is a 3, 4, 5 right triangle. And since it is a right triangle, that means that D, which is the circumcenter, is on the hypotenuse, and it's the midpoint of the hypotenuse. And therefore, the circumradius is half of the hypotenuse. So that's 65/2. Hence, m plus n is equal to 65 plus 2, 67. If that's all clear, I'm gonna show 11. For this problem, you have to find what the root of 27 is less than and greater than. To do this, we have to do some estimation. We could compare powers of 3 to powers of 2. Let's start by finding what it's less than. We can observe that 3 cubed, which is 27, is less than 32, or 2 to the power 5. Therefore, we can write this as 3 to the power of 3 times 9, or 27 to the power of 9. This is less than 32 to the power of 9, which is equal to 2 to the power of 5 times 9, which is the power of 45. And now we'll determine what 2 to the power of 27 is greater than. We guess that should be greater than 2 to the power of 40. To see this, observe that 3 squared is more than 2 cubed. Now we could write this as 3 to the power of 2 times 13 plus 1, which is equal to 9 to the power of 13 times 3, which is greater than 8 to the power of 13 times 3, greater than 8 to the power of 13 times 2, which is equal to, solve it, 2 to the power of 40. So indeed, 2 to the power of 27 is between 2 to the power of 40 and 2 to the power of 45. So 5k is 40 and k is 8. Does everyone understand this? All right, if so, I'm gonna hand it over to Gracelyn to explain problem 12 and so forth.
Okay, Jennifer, would you be able to stop sharing your screen since I have a separate screen available? Okay, so can everyone see my screen? Okay, so from now, if you have questions, just send them to me, since then I can just directly answer them. And yeah, after I go over 15, Chris can start going over the others. So you can ask then, but for now, I'll just start explaining. Okay, so for number 12, you can note that there are technically just 3 types of numbers. By the way, I'm not able to paste the problem directly, so you can just read off of either the PDF or the form. So They're either 0 mod 3, 1 mod 3, or 2 mod 3. Okay, and note that you can't have 3 of the same type. So and you also can't have one of each type, or at least one of each type, because then 0 plus 1 plus 2 is equal to 3. And then that's a number divisible by 3. So by these restrictions, if you want to maximize the numbers you can choose, then you can only choose 4 numbers really. Of course, having not 3 of the same type or 1 of each type. There's multiple examples of this really though. So one example is 0022, or no, I think my screen froze. Yeah, okay. So one example is 0022. A lot of you probably thought of other examples too, but okay, yeah. So are there any questions on number 12?
Could you have one of each type and then 2 of another type?
So if you do, so the issue is that you can't have one of each type at all, because as long as you have one of each type, then you can always choose 3 numbers that have 0, 1, and 2. And just because of like modular arithmetic, 0 plus 1 plus 2 equals 0 mod 3, which means that it's a number divisible by 3.
Okay, thank you.
Okay, yeah. So my screen has not unfroze yet, so I'll just reshare. I'm sorry. And then next I'll go over number 13. Okay, so
wait, how is it 4 numbers again?
Okay, so the issue is you can't have 3 of the same type and 1 of each type, right? So, sorry, do you think the answer should be more or less? Because then I can kind of help answer it better.
More.
Okay, so if you add like another number, okay, so like what numbers do you propose that you could have really? Because this kind of works off of the pigeonhole principle, right? Where max you can have 2 different types, right? So 2 different types. And you can't have 3 of the same type. So you can only have 2 of one particular type. Because otherwise you go over either of the restrictions if you add a number. Does that make sense?
Oh, yeah.
Okay, so for number 13 then. Okay, so we kind of want to work backwards here. So we know that Olivia takes the last 3. Right, and Michelle takes half of the remaining and 2 more after that. So Michelle first takes 2, and then she takes half of the remaining candies. So it kind of implies that she takes 5 because it's 3 plus 2, right? So then, so she takes 2 candies and then 5 candies. And Hannah takes 1 candy along with 1/3 of the remaining candies. So here we have that these 2 combined are 10 candies. So these would be 2/3 of the candies. And therefore 1/3 of the candies that are remaining is 5 candies. And she takes 1 candy before that. So that is 6 candies. So then you just have 10 plus 6 is equal to 16. Okay. Are there any questions? Okay, so if not, let's move on to 14. Okay, so we're given that xy is equal to x plus y plus 14, and yz is equal to y plus z plus 23, and xz is equal to x plus z plus 39. Okay, so one kind of trick that you might have prior knowledge of is Simon's favorite factoring trick. If any of you guys know AOPS, then you've probably heard of it. But you can rewrite these as and then this will factor into, and note that it changes to 15 because on this side you technically add 1. Okay, I think my screen froze again. Okay. And then you do similar processes for the other 2 equations. So I'm not going to write out as much, but this would be and also apologies if my z's kind of look like 2's. Yeah, okay. So from here, it's kind of like guessing and checking your answers. So you kind of want to use a bit of common sense. Okay, so I'm not really sure what was just sent in the chat if the person who sent it wants to clarify their question. Okay, but if not, then we have, you can kind of see that 15 has the factors 5 and 3, apart from 1 and 15. 24 has 2 and 12, 3 and 8, and 4 and 6. And 40 has 2, 24, 10, 5, 8. So you want to find like the 3 kind of pairings of divisors that basically compose X, Y, and Z, or make up X, Y, and Z. So you kind of can see that you have these ones that are in common. Okay, and this basically just means that x minus 1 is equal to 5, y minus 1 is equal to 3, and z minus 1 is equal to 8. So then you can add all of these up, which is x plus y plus z minus 3 is equal to 16. Sorry. And then add 3 on both sides to get that x plus y plus z is equal to 19. So yeah, I don't know, your calculator might give you another answer, but generally this should be solved using just algebra. It doesn't really require much. But yeah. Okay, so does anyone have any questions on this one?
Wait, how do you know x minus 1 is 5 and y minus 1 is 3 and all that?
Yeah, so that's kind of from looking at the divisors of 15, 24, and 40.
Oh, now I get it.
Yeah, because you're given that x, y, and z are positive reals. So they're more likely than not integers. Okay. So then moving on, we have 15. Okay, so for this one, it again requires a bit more common sense with like knowing days. But yeah, okay, so you know that every Friday is, or the next Friday will be 7 plus the current Friday's date. And to only have even Fridays, this basically just means that all the Fridays are 14 days apart. Because if they're 7 days apart, then one of them's going to be odd at least. And that's not what the question kind of asks you. So you can kind of reason that this is like part of a calendar, right? That you can't really have any or too many like repeating dates. I don't know if that makes sense. So since they're even, we have to put the largest even date to kind of make sure that we have enough space. 30 minus 14 is 16, and then 16 minus 14 is 2. The reason I got this is because if you started from, I mean, you can't really start from 1 because you're looking at even numbered dates. So you start from 2. And obviously in a month, you can only have a maximum of 31 days. So you also want to make sure that your number doesn't go above that. And then from here, we're asked what day of the week is the 24th. And you can kind of find this by kind of filling it in like a normal calendar where it's just 7 days apart. And then the 24th would be here, which is a Saturday. So then the 24th of the month is Saturday. Okay, so does anyone have questions on number 15? Okay, so if not, then I'll stop sharing. And now you can send whatever questions you may have on problems from 16 to 25 to Chris. And he will start going over them as soon as he gets enough responses. Yeah, as a reminder, please send any problems that you want to have gone over to Chris instead of me, since I will not be going over questions from 16 to 25. Yeah, just because I just got a question, the answer for 15 was Saturday.
All right, so I have the questions 16, 17, 22, 23, and 25. Let's start with 16. Okay, I'll accept 19, 20, and 21. All right. So I'll wait for some more questions, and then I'll start going over things. All right, so basically every question except for 18 and 22. Okay, so every question except for 18. All right, so let's start with problem 16. So problem 16 is asking for the least possible value of this expression over all real numbers x. And so we see a product of these four expressions that form an arithmetic sequence. So one thing we can think of is we can pair up these two terms and pair up these two terms. And when we pair up the terms on the edges, what we get is x squared plus 8x plus 7. And when we pair up the terms that are inside, we get x squared plus 8x plus 15. And then we have the plus 2021. And so we want to find the least possible value of this. And when we see this expression, what we think is we can use difference of squares, because we can rewrite this as x squared plus 8x plus 11 minus 4 times x squared plus 8x plus 11 plus 4, and then plus 2021. And so once we've written this as this form, in this factored form, we can apply difference of squares. So what we're going to have is x squared plus 8x plus 11 all squared minus 16, and then plus 2021. And so now we have a perfect square and also some constant that we're adding. So we have x squared plus 8x plus 11 squared plus 2005. And since x is a real number, so is x squared plus 8x plus 11. So this is greater than or equal to 2005. And so the last thing we have to check is whether or not 2005 is actually achievable. And to figure out whether it's achievable, we just have to see if this has a real solution. And you can see that this has a real solution because when you do the quadratic formula, you see that the discriminant is greater than or equal to 0. And in fact, when we let x be equal to -4 plus or minus 2 root 5, this expression that we want to find is actually equal to 2005.
It should be just root 5.
Yeah, sorry, it should be just root 5. Nice catch. All right, so that gives us a final answer of 2005. And so the answer to this one is B. All right, so somebody asked, how do we know which ones to pair? So here we have an arithmetic sequence, right? So x plus 1, x plus 3, x plus 5, x plus 7. And the reason we want to pair x plus 1 and x plus 7, and also x plus 3 with x plus 5, is because we know that when we multiply each pair, we're going to get x squared plus 8x plus some constant. And so once we get this, we're going to get basically two terms that differ by a constant. And so when we have two terms that differ by a constant, we can apply difference of squares. And so this is why we want to pair specifically these two and these two. All right, are there any questions?
Wait, so if the roots of x are not so if the roots of x are real, that means that it can be 2005, right?
Yeah, since the roots of x are real, what that means is that when we when we plug in those values of x, the roots of x or of this thing, what this basically says is that there are real numbers such that this expression, x squared plus 8x plus 11, is equal to 0. So what that means is that when we plug in x is equal to -4 plus or minus root 5, we're going to get that this expression will be equal to 0 squared plus 2005, which is equal to 2005. And this shows that 2005 can be achieved. All right, so that's problem 16. I'll wait for any other questions before moving on to problem 17. All right, I'm not getting any more questions, so we can move on to problem 17. So in problem 17, we're told that a person draws a right triangle with hypotenuse BC, and it has length 1, and it also has angle measures of b equals 60 and c equals 30. So let's start to draw our diagram. So let's start by drawing our triangle CAB. And since BC is the hypotenuse, what that means is that angle A is the 90-degree angle. And also, we know that this is 60 degrees, this is 30 degrees. And so what Paul does next is he draws the segment connecting A to the midpoint of the hypotenuse. So let's draw our midpoint. So this will be our midpoint D. And we connect A with D. And then what he does next is he constructs a line that is perpendicular to AD and passes through D. So we're going to draw some kind of line like this. And it's perpendicular to AD, and also it passes through D. So we're going to have this right angle here, and this line, along with AB and AC, will form a triangle. So we can see our triangle. So these are the 3 vertices of the triangle, and we want to find the area of this triangle. So the way we do this is, first, we notice that this triangle is a right triangle. So in order to find its area, all we have to do is to find the lengths of its 2 legs. And let's just add some notation here. So let this point be x, this point be y. All right, so what we want to find is the area of AXY. And this is equal to 1/2 times AX times AY. And so what it suffices to do is to find AX and AY. So let's try to find AX and AY. All right, so since BC is the hypotenuse of a right triangle, when we mark its midpoint D, we're going to have that D will be the circumcenter of ABC. And what that means is that CD is equal to AD is equal to BD. And also, since this is a 60-degree angle, this is also a 60-degree angle. And so this is 30 degrees. And so we have these 2 angles, and since we know that the hypotenuse BC has length 1, we can calculate each of these equal lengths to be 1/2. Right, so now we see that triangles ADX and YGA are both 30, 60, 90 triangles. So in particular, we're talking about this triangle and also this triangle. So these two triangles are both 30, 60, 90 triangles because they both have a 30-degree angle. In this triangle, this angle is 30 degrees. And also they both have a right angle over here. And so since we know the length of AD, we can find that AY is equal to 2 times AD. So it's 1. And AX is equal to 2 over root 3 times AD. So it's equal to 2 root 3 over 3. Sorry, this is a 1/2. So AX is actually equal to root 3 over 3. And so when we plug these two lengths in, we're going to get 1/2 times 1 times root 3 over 3, which is equal to root 3 over 6. And that's our final answer. So we've found the area of this triangle to be root 3 over 6, and our answer is C. Okay, are there any questions?
Wait a second. For AX, how did you find the length of AX?
Okay, so to find the length of AX, we first noticed that since the triangle XAG has a 30-degree angle over here,
Yeah.
and it also has a right angle, which is up here, we see that this triangle is a 30, 60, 90 triangle. And we can use the ratios between sides of a 30, 60, 90 triangle to find that the length AX is equal to 2 over root 3 times 1/2.
Oh,
And so,
for AY, you do the same thing for the red triangle?
yeah. Mhm. All right, so next, let's talk about problem number 18. So somebody asked about 18. So Sarah and Alvin are playing a guessing game. And Alvin will pick a positive integer that is less than 500. And Sarah wants to guess Alvin's number. And Alvin tells her that this number leaves a remainder of 3 when divided by 5, a remainder of 5 when divided by 7, and a remainder of 11 when divided by 13. And so Sarah wants to guess Alvin's number. So let's say Alvin's number is X. So this is going to be Alvin's number. Then, since this number leaves a remainder of 3 when divided by 5, X plus 2 is going to be a multiple of 5. So this is divisible by so we know that X plus 2 is going to be divisible by 5. And since it also leaves a remainder of 5 when divided by 7, X plus 2 is going to be divisible by 7. And similarly, since it leaves a remainder of 11 when divided by 13, X plus 2 is going to be divisible by 13. So X plus 2 is going to be divisible by 5, 7, and 13. And so X plus 2 is divisible by the product of these three, which is going to be 455. And note that since X plus 2 is going to be a positive integer less than 502 and greater than 2. What this means is that X plus 2 has to be equal to 455. And so X has to be equal to 453, and our answer is D. All right, any questions? Yeah, you could have also used CRT. It's basically the same idea. All right, so next let's move on to problem number 19. So in problem number 19, we're told that a standard six-sided die is rolled. And then we're going to remove one dot from the top face. And after removing the dot, we want to find the probability that you will roll an even number. So when you remove the dot, there are either two things that can happen. There are two things that can happen. So you either take an even side and turn it into an odd side, or you take an odd side and turn it into an even side. So the probability that you will take an even side and replace it with an odd side is going to be 1/2. And the probability that you take an even side and you turn it, so like the probability that you take an even side and turn it into an odd side is going to be 1/2. And also the probability that you take an odd side and turn it into an even side, it's also 1/2. So we have two probabilities here, 1/2 and 1/2. And in our first case, what happened is we replaced an even side with an odd side. And in the second case, we took an odd side and replaced it with an even side. So in our first case, we're going to be left with 4 odd sides and 2 even sides. And so the probability that you roll an even number is going to be 1/3. In our second case, you're going to have 2 odd sides and 4 even sides on your die after you remove a dot. And so the probability that you will roll an even number is going to be 2/3. And when you add these two probabilities, you get 1/2. And so the answer is answer choice B.
With an answer like 1/2, is there a way we could have seen it sooner?
Yeah, so one thing you can notice is that there's not really there's not really a big difference between rolling an even number and an odd number. And so throughout the process, the probability that you will roll an even number or an odd number is always going to be the same because it's symmetric. And so the answer would be 1/2 because the probability that you roll an even number and the probability that you roll an odd number are going to be the same. So they're both 1/2. That is a way you could have saw it sooner, but I guess this would be a more rigorous way to prove that the probability is going to be 1/2. All right, so that's problem number 19. Let's move on to problem number 20. So we call a 2-digit number charitable if it's divisible by 7, and also the two-digit number obtained by reversing its digits. So we're going to swap its 2 digits, and the new number is going to be a 2-digit number. This number is going to be either divisible by 13 or it has at least 5 positive integer divisors. And we want to find the sum of all charitable numbers. And one thing you could do is to list. So let's take all of the 2-digit multiples of 7. So let's see. We have 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, 91, and 98. So these are our 2-digit multiples of 7. Okay, and so what we're going to do is we're going to reverse all of these 2-digit multiples of 7 and check if it's this new 2-digit number is divisible by 13 or has at least 5 positive integer divisors. So let's reverse these. 41, 12, 82, 53, 24, 94, 65, 36. 70 reversed is not a 2-digit number, so we can cross that out. 77, 48, 19, and 89. And so now what we do is we check each of these numbers to see if it's divisible by 13 or it has at least 5 positive integer divisors. We can see that 41 does not have 5 positive integer divisors, and it's also not divisible by 13, so we can cross that out. 12 has at least 5 positive integer divisors because it has 6. So let's circle 21. 82 is neither of these, so we can cross this out. 53 as well, we can cross this out. 24 has 8 positive integer divisors, so we can circle this. 94 has 4 positive integer divisors, and it's also not divisible by 13, so we can cross this one out as well. 65 is a multiple of 13, so let's circle this. 36 has 9 positive integer divisors, so let's circle this. 77, we cross this out. 48 has 10 positive integer divisors, so let's circle 84. And these two we also cross out. And so we're left with 5 numbers that are charitable. And we can easily see that we have found all 5 numbers, or all of the numbers that are charitable. So let's add these. And when you add these, you can add these up, you're going to get 266. And that's answer choice D. All right, somebody asked if there's a method other than brute force. I believe there probably is, but since there are not that many 2-digit multiples of 7, brute force is not going to be, it's not going to take too long. So I think if you try to not brute force, it'll kind of be more complicated because you'll have to find a way to not brute force. And yeah, so I think listing all of these numbers out and checking each of them is actually going to be probably the fastest way to solve this problem. All right, so now let's move on to problem number 21. So in problem number 21, we have Tommy, who starts reading a book with numbered pages. And so for every page he reads, he adds up all the digits of the page numbers. So for example, if he reads 14 and 15, his sum will be 1 plus 4 plus 1 plus 5, which is 11. And so Tommy starts reading on page 13. He skips page 24 and he keeps reading until he ends up with a sum of 232. And we want to find the number of the last page he read. And so we're going to start from 13. So we can start from 1 plus 3. And we have 14, 1 plus 4, 1 plus 5, 1 plus 6, and so on. And so one thing you can notice is that from 13 up until 19, the sum of the digits of each page is going to be 4, 5, 6, 7, 8, 9, and 10. And so we can add all of these up So those are going to be the first 7 pages he reads. So we have 4 plus 5 plus 6 plus ... plus 10. And these are for the page numbers from 13 to 19. And then from page 20 to 29, we're going to have 2 plus 3 plus 4 plus 5, and so on, until 11. And we're going to have to exclude page 24. So we subtract 6 from the whole thing. And so we can keep on adding. From 30 to 39, we're going to have 3 plus 4 plus 5 plus all the way until 12. And we can keep on doing this. We can see that this sum is going to be, or rather this whole sum is going to equal, I believe, 43. And we can also find the sums of each of these. So this is going to give us a sum of 65. This is going to give us a sum of 75. And so when we add these three, we see that we haven't reached 232 yet. And so we can keep on going from page 40, until page 49. And this is going to give us a sum of 85. And when we add these 3 page numbers, these 3 sums, we're going to get 268, which is too much. So we know that we're not going to include all the page numbers from 40 to 49. Rather, we're going to include some of them. So we start from here. This is a sum of 183. And we add 4, add 5, add 6, add 7, add 8, and so on, until we get to a sum of 232. And so we can do some experimenting. So once we add page 40 in, our sum is going to be 187. When we add page 41, our sum is going to be 192. So we can keep on writing each of these sums after each page is added. And finally, when you add 10, which is the sum of digits of 46, the total sum will be 232. And so now we have the page number that gives us a sum of 232. And this page number is 46. And so 46 is our final answer. All right, are there any questions? All right, so I'm not receiving any questions, so we can move on to problem number 22. So we're given a triangular pyramid, and this triangular pyramid is WXYZ. And we're told that face XYZ of this triangular pyramid has side length 6, and it's also an equilateral triangle. And in addition, we know that WX, WY, and WZ are all 5. And we want to find the volume of tetrahedron IXYZ, where I is the incenter of face WXY. So first we can note that the volume of the tetrahedron IXYZ, we can find it in terms of the volume of WXYZ. So let's first draw a picture. So let's have X, Y, and also let's have W in front. All right, let's start by drawing the base. So we have these three, and we also have let's also draw these three. And so we have our tetrahedron here. And let's say this is W, this is X, this is Y, this is Z. And so WX, WY, and WZ are all 5. And XZ, YZ, and XY are all 6. And so one thing you could do is you can find the volume of tetrahedron WXYZ. You drop the height, and the foot of the height will be on the centroid, or rather the circumcenter of XYZ, which is an equilateral triangle. And so you can find that this length is equal to 2 root 3. And so our height is equal to root 13 by Pythagorean theorem. And so the volume of WXYZ will be 13 times root 13, 1 over 3 times root 13 times the area of the base, which is XYZ. And that's going to be equal to 9 root 3. So the volume of WXYZ will be 3 root 39. And so here you can kind of guess that the answer will probably be 9 root 39 over 8 because none of the other answer choices include the number root 39. But to solve this, we're gonna draw out our face, W, X, Y. And we're gonna draw this in circle. So in this triangle, we can see that we can mark these lengths, and you can find that the in radius is equal to. You can find that the in radius is going to be equal to. Let's see. So let this be R, and then let's mark some. Okay, let's let this point be D, this point be I, and this is a right angle. So firstly, WG is equal to 4 because of Pythagorean theorem. And secondly, since triangle W, let's call this T, triangle WTI is similar to triangle WDY, we can calculate IT to be equal to, this is the in radius. We can calculate IT to be equal to WT times 3/4. And so what we can do here is we can find WT, and since these are tangents to the in circle, TY is also equal to 3 and WT is equal to 2. So R is equal to 3/2. And so from here, we can calculate ID over WD to be 3/2 over 4, and that's 3/8. And so to find volume of tetrahedron IXYZ, we can use the ratio of the smaller tetrahedron to the larger tetrahedron volume, which is going to be ID over WT. ID over WD. My bad. So we're going to find this final volume to be 3/8 times the volume of WXYZ, which is going to be 3 root 39. And that gives us a final answer of 9 root 39 over 8. And that is our final answer. All right, so I'll wait for any questions before moving on to the next problem. Okay, so next, let's talk about problem number 23. So we're dealing with this floor function, and we want to find the sum of a bunch of floor functions. So one thing we can do is we can pair up some of these things that we want to add. And so in particular, let's consider this. And we can see that when we add these two, so first we're going to have this. This is equal to, we can take out this integer, and we're going to be left with this. And what we can notice is that this, these two numbers over here, they usually sum to -1. And when k is a multiple of 2022, these two will sum to 0. So we're going to have a bunch of 20. We're going to have a bunch of 2021s, and then we're going to have the sum of a bunch of these as well. So first we can notice that if we change this sum to be up to 2021, then it'll be easier to find the sum of all of these floor functions. And so we take 2021 and we multiply it by 1010 because that's the number of pairs we have. And we want these pairs to sum up to 2022. And so we also have to be careful of the number 1011 because it pairs with itself. And so when you add a bunch of these sums, what you're going to get is that you're going to get a bunch of -1s from a bunch of these sums. And also you're going to get whatever we get when we plug in 1011. And when we plug in 1011, we get 1010. And so we have these two terms, and then we also want to sum up all of these terms. And so we're going to subtract 2021 because, sorry, we're not going to subtract 2021. We're going to subtract the number of such terms, which is going to be 1010. And then, so once we're done with this, we still have to add on, you see, like we started with a sum from k equals 1 to k equals 2023. And what we calculated here is the sum from k equals 1 to k equals 2021. So we still want to add on the values for k equals 2022 and k equals 2023. And we can calculate each of these when k equals 2021, sorry, when k equals 2022. Then our sum is going to be, or sorry, our floor function, or floor, is going to be the floor of 2021 times 2022 over 2022, which is going to be 2021. And then we still have to add what we get when k equals 2023. So that term will be this. And we can use our difference of squares to find that it's equal to this. And we can see that this is also equal to 2021. And when we sum all these up, the answer we're going to get is 2045252. And that is our final answer.
How did you know that the positive floor function and the negative floor function would be like opposite each other?
So when we look at these, so usually we're going to have a number, a negative number, and also, okay, so let's see. So let's say we have numbers like negative 3.7 and 3.7. If we take their floor functions, this will go to negative 4, and this will go to 3. So typically when we don't have an integer, when we have two numbers that are negative of each other, when we take their floor functions, one is going to have a greater magnitude than the other. And specifically, the negative one will have a greater magnitude. And its magnitude is going to be greater by 1. And so when we add these two, we're going to get negative 1. And we can't say this when the number inside the floor function is an integer, because when we have something like negative 3 and 3, negative 3 will go to negative 3, 3 will go to 3, and everything becomes 0 because the negative 3 and the 3 will cancel out. So we employed this here by noticing that whenever k is not a multiple of 2022, these two, or rather this expression inside the floor function, is not going to be an integer. And so these two 4s will sum to negative 1. All right, so
Thank you.
no problem. So are there any other questions? If not, we can move on to problem number 24. So for problem number 24, we have this long game. We have this game, and so A and B take turns tossing a weighted coin. And this weighted coin shows heads 1/5 of the time and shows tails 4/5 of the time. And we're told that in round 1, A and B toss coins alternately. And A goes first. And the rule of this round is that the first person to toss a head will win. And in every round after this, A and B will toss coins alternately again, but with the loser of the previous round starting the round. And this will go on until somebody tosses a head. And we're told that in each round, the first person to toss a head wins. And we want to find the probability that our first person A will win the 5th round. So first we can find the probability that the first person in a round will win the round. So to find this probability, we're going to see that either the first person who goes wins, gets a head immediately. So that's going to happen with 1/5 chance. And if the first person is not that lucky and does not get a head on his first try, he can still win. So there's a 4/5 chance that happens, and what he needs is for B to also fail. And that's going to give us a 4/5 chance. And the next thing he could do is he can win the next round, or win the next, throw the coin and get it on his second try. And that'll also cause him to win. Or he wins on his third try. And in order for that to happen, the first 4 flips have to all be fails. And the 5th one is a win for the first player. And we keep on finding this. So we keep on adding all of these terms, and we're gonna get an infinite geometric sequence. And in fact, this is an infinite geometric series. And we can calculate its sum to be this. So in any round, the first person who goes will have a 5/9 chance of winning the round. And so let's denote P of n as the probability that that this person A wins the nth round. And so we can write a recursive relation between P of n and P of n minus 1. So either A loses or A wins the previous round, and that's going to happen with probability P of n, Pn minus 1. And the probability that he wins in this case is going to be 4/9 because he goes second. The loser goes first, and since he won the previous round, he goes second, and he has a probability of 4/9 of winning. Or he doesn't win the previous round with probability 1 minus Pn minus 1. And in this case, he goes first. So he has a 5/9 chance of winning. And we can rewrite this as 5/9 minus 1/9 Pn minus 1. And then we can notice that P of 1 is equal to 5/9 because he goes first in the first round. And so given P1, we can find P2 and P3 and P4 and P5. And you can see that you can use induction to prove that actually Pn is equal to 1/2 plus 1/18 times negative 1/9 to the n. You don't really need to know this, but so like when you are doing this problem, one thing you could do is to just plug in P1 into this recurrence relation and get P2, and then we can get P3 and then P4 and so on. And we want P5, and so P5 we see is going to be equal to, after you do the calculation, you're going to get 29,525 over 59,049. And this gives us a final answer of 574. And that's answer choice C.
When you found the closed form of the recursion, did you just like continue plugging in like successive Pn's and then like reduce it all down to P1? Because I don't really know how to do it by induction.
So we have this recurrence relation, and we can see that since P of 1 is equal to 5/9, we can see that this works for n equals 1 because 1/2 plus 1/18 times negative 1/9 is going to be 5/9. And so what we want to do is we want to show this for all n, all positive integers n. And so we can plug in P of n is equal to 5/9 minus 1/9 times the previous expression, 1/2 plus 1/18 times negative 1/9 to the n minus 1th power. And when you do the simplification, you're going to get that Pn is going to be exactly this expression. So what we kind of do is inductively find the next term, and on and on and on.
Okay,
So that's how we.
Oh, sorry. So once you had Pn equals 5/9 minus 1/9 Pn minus 1, would you then like do Pn minus 1 equals 5/9 minus 1/9 Pn minus 2 and then like plug it in and keep on going?
All right, so what we're going to do is, so since we already know that P1 is equal to 5/9, we can find P2 afterwards, since we have like this recurrence relation. And so we're going to have 5/9 minus 1/9 times 5/9. So what we're doing is we're plugging in 5/9 into this recurrence relation.
Oh, okay, I see. Thank you.
All right, so that's question number 24. Are there any questions? Before we move on to our final question. All right, so finally we have problem number 25. And so we have this humongous diagram, and we're told that we have this right triangle ABC and its isosceles. And since it's this triangle is non-degenerate, so since AB equals BC, angle B has to be the right angle. So we can mark this angle as 90 degrees, and we let E to be on AB and F to be on BC, so that EF is parallel to AC. And then we take the angle bisector of this right angle, and we intersect it with the circle at X. And next thing we do is we intersect segment EC with the circle with diameter BC. And this intersection is going to be N. And so one thing we can notice here is that this is a right angle because N is on the circumcenter. N is on the circumcircle with N is on the circle with diameter BC. And so this angle is going to be a right angle. And the next thing we do is we extend Bn to meet AX at G. And in addition, we have this strange condition, and we want to find the square of the cosine of angle NFX. All right, so first, how do we approach this? Well, so the first thing we can do is we can notice that NFX looks like a right triangle. And so let's see if we can try and prove that angle N in triangle XNF is actually a right angle. Because once we know that, we can easily find, or not easily, but we can find the cosines of NFX more easily. So, all right, so the first thing we do is we try to prove that this is also a right angle. And so the way we do this is by using cyclic quadrilaterals. So the way we do this is we can first notice that since GNC is a right angle and GXC is also a right angle, the quadrilateral GNCX is cyclic. And so we have this quadrilateral is cyclic. And also, since angles ENG and EAG both are both 90 degrees, we see that these 4 points A, E, N, and G are also cyclic. And so we can see that by power of a point, Bn times Bg is equal to Be times Ba, and Be times Ba is the same thing as Bf times Bc, because B equals Bf and Ba equals Bc. And so now what we have is that Ng, F and C, Ng, C, and F are on the same circle. And earlier we noticed that we have these 4 points, G, N, C, and X. So N, G, X, and C are in the same circle. So these points are all on the circumcircle of triangle NGC. And so these 5 points lie on the same circle. And since XCF is a right angle, so is XNF. All right, so now we've proven that XNF is 90 degrees. And let's move on with the problem. So next thing we can do is we want to use the condition, this weird condition somehow. We want to use this. So let me erase this. And we have this condition that Gn times Nb is equal to 2En times Nc. And one thing you can notice is that by similar triangles, En times Nc is just Bn squared. And immediately, this simplifies this weird condition by a large factor. And we can cancel out Bn from both sides, and we're going to get Gn is equal to 2Bn. And so, from here, we can see that Bn over Bg is equal to 1/3. Oh, so here we use the fact that En times Nc is equal to Bn squared. And one way you can see this is by realizing that triangles ENB and BNC are similar. And since they're similar, we see that Bn squared is equal to En times Nc after you write out the side ratios and also just cross multiply. And so we see that Bn over Bg is equal to 1/3. And let's drop the altitudes from N to A, B, and BC. And let's call these feet of the altitudes R and K. And since Bn over Bg is equal to 1/3, by similar triangles BRN and BAG, BR over BA is also 1/3. And so, since we're looking for a cosine of an angle, we can allow AB to equal anything. So let's just suppose AB equals 1. And so what this tells us is that BR is equal to 1/3. So once you have BR is equal to 1/3, you can do some trigonometry. So if we suppose that this angle is equal to theta, then we can see that Bn, this is BR, Bn is equal to BC times sine theta. So Bn is equal to sine theta. And so Nk, or rather Br, is equal to, since this angle is theta, because this angle over here is 90 minus theta. So what this tells us is that Br is actually equal to sine theta times cosine theta. And so we have an equation involving theta and 1/3. So sine theta times cosine theta is equal to 1/3. And we can double both sides, and we're going to get 2 sine theta cosine theta is equal to 2/3. And by the double angle formula for sine 2 theta is equal to 2/3. And so we can find that cosine 2 theta is equal to √5/3. And this is because theta is an angle that is less than 45 degrees. So 2 theta is going to be an acute angle. And so from here, we can quickly calculate that cosine theta is equal to the square root of 3 plus √5/6. And so what we can do next is we can find the lengths of NK, KF, FC, and CX. So firstly, NK is equal to Bn, or Nk is equal to Br, so it's equal to 1/3. And next we can calculate Bk. And so Bk, we can calculate to be Bn times sine of theta. So it's also equal to, or an easier way to calculate this is by just noticing that Bk is equal to Nr, which is Br times tangent theta. So this is equal to Br tangent theta. And since Br is 1/3, this is equal to 1/3 tangent theta. And since we know that cosine theta is equal to this, we can calculate by using cosine theta squared plus sine theta squared is equal to 1. We can calculate that sine theta is equal to the square root of 3 minus root 5 all over 6. And so we can calculate tangent theta to be sine theta over cosine theta, which is going to be this. And you can simplify this, and what you're going to get is you're going to get 1/3 times 3 minus root 5 all over 2, which is equal to 3 minus root 5 over 6. And also, you can find BF, because BF is equal to BE. And BE, so BF is equal to BE, and BE is equal to BC times tangent theta. So this is just going to be equal to tangent theta, since BC is 1. So we're going to end up with 3 minus root 5 over 2. And when we subtract these two lengths, we're going to get that FK is equal to 3 minus root 5 over 3. And also, we can calculate FC. FC is going to be our total length BC minus BK and then minus KF. And so when we subtract all of these, we can see that FC is going to be equal to 1 minus 3 minus root 5 over 6 minus 3 minus root 5 over 3. And when you do the calculation, this comes out as root 5 minus 1 all over 2. And XC is equal to 1. And so now we can find cosine squared, cosine of n of x squared. Since n of x is in a right triangle, cosine squared of n of x is equal to just nf squared all over fx squared. And we can use Pythagorean theorem on each of these. So this will be nk squared plus kf squared over fc squared plus cx squared. And we can see that nk squared is just going to be 1/3 squared. So we're going to have 1/9. Kf squared is going to be this expression squared. Fc squared is going to be this expression squared. And xc squared is going to be 1, since xc is equal to 1. And from here, you can calculate this top to be 14 minus, or 15 minus 6 root 5 over 9, which is 5 minus 2 root 5 over 3. And our denominator is going to be equal to, I believe, so this is 5 minus 2, right, this is going to be 3 minus root 5 over 2, and we're going to get 5 minus root 5 over 2. And so when we calculate this, our final answer is going to be 3 minus root 5 all over 6. And so when we write it in this form, m is equal to 3, n is equal to 5, k is equal to 6. And we sum those off, and we're going to get a sum of 14. So 14 is our final answer. All right, so that's the last problem. All right, so somebody asked, did anyone solve this problem? Let me see. So seems that 6 people solved this problem. So good job to those 6 people. Is this problem AMC 10 level? I would say this is just like a problem that could be suitable for like problem 25. Another thing is that if I just changed cosine squared of nfx to nf squared over xf squared, there's not going to be any trigonometry. And then this could potentially be an AMC 10 problem. But this seems, I think this problem is a bit harder than usually the scope of the last 5 problems on the AMC, but this problem is going to be good practice. This would be like a good problem 25 on an AMC 12. It's not beyond the scope of an AMC 10 problem. So yeah, this problem 25 on this set is meant to be like a challenging problem, and it's meant to be like harder than the other problems. All right. And also there's a way you can do this without any trigonometry. You can replace all of these sine thetas and cosine thetas with x's by substituting, by setting BE equals BF equals x. And it's going to involve a similar amount of computation. So yeah. All right, that concludes the last problem for today. And so, yeah, that's it for our discussion of 2021 Logistem mock AMC 10. And so, since we're quite a bit over time, you guys can all leave if you want to. And if you have any other questions, you can say. And yeah, so that will be all for today. Thank you all, and everyone have a great day.